Hi guys, this is the next video, Docker networking. In the last video, we looked at Docker registries and volumes. In this video, we're going to take a look at networking and user-defined networks. Networking is an important part of Docker. By default, Docker comes with 3 networks that we can inspect by executing the docker network ls command. It should produce output similar to this. Let's explain the different networks. The first network is Bridge. This is the default network. It is an entirely different stack from the host machine, with a different IP range in the bridge mode. The containers created without specifying the network are attached to the default bridge network. The next network is Host. In this network, containers share the network stack with the Docker host. If you inspect the configuration in the container, you will find that it is exactly the same as in the Docker host. The last one is None. This is easy to guess. The container gets attached to no network, just the loopback interface in the container. Now it is time to look at some examples. We're going to use BusyBox, which is the Swiss Army knife of the Docker images. It has several Unix tools that we could benefit from, but in this case, the characteristic that is going to benefit us is the fact that it is a functional Linux on a reduced space. Let's run this command. As you can see, we gain root access to a running container. The next step is to execute ifconfig inside the container. It should give us 2 interfaces, ETH0 and LO. The IP might change, but you should see these 2 interfaces. Comparing the IP with the IP in your Docker host, we can validate the fact that the container is running in the bridge network, as the IP and network are completely different. Now, let's spawn another container with BusyBox in a different terminal. By now, we should have 2 BusyBox instances running. They should have consecutive IPs. In my case, the IPs are 172.17.0.6 and 172.17.0.7. If we go back to the terminal of the first instance of BusyBox, we can ping the second container by IP. This is because they both belong the same network, which is the default bridge one. In order to run the containers in the host network, we just need to pass --network equals to host flag to the docker run command. Our container is sharing the network stack with the Docker host. But be careful if you're on Mac or Windows. The Docker host is a virtual machine, so don't attempt to access it through localhost. You will need to find the IP of the virtual machine running Docker. Let us use the user-defined networks. It is also possible to create custom and isolated networks in Docker. This is interesting from the security point of view, as it enables us to segregate different containers on the network level so we can enforce a higher level of access control. In order to create a network, we just need to execute the docker network create command. And that's it. Well, that is a simplistic approach, but it works as expected. As you know, networking is a complicated subject, so Docker provides options to customize ranges, masks, and other parameters. The user-defined networks are of the type bridge. Once the network is created, you can run new containers in that network using this command on a new terminal. As expected, these containers will be isolated from the other networks. In this case, the 2 containers are launched in the bridge network. In my case, the third container, the one just launched, has the IP 172.18.0.2, whereas the 2 launched in the bridge network are 172.17.0.6 and 172.17.0.7. Issuing a ping command between containers in different networks results in 100% packet loss. In this video, we've looked at Docker networking. In the next video, we will see Docker Compose.